Hello students, this is Shachi. Welcome to my channel Crack Chemistry. Today I am going to explain a class 12 topic. The name of the topic is Henry's Law and its applications, and chapter's name is Solutions. Students, before starting, I want to remind you to subscribe my channel for getting information about further important uploads, and press the like button if you like this video and share this video with your friends also. So now come with me and let's crack chemistry. Our topic is Henry's Law and its applications, and the chapter's name is Solutions. Students, Henry's Law explains the solubility of a gas in a liquid. Students, different gases are soluble in water and other solvents to different extent. For example, oxygen gas is slightly soluble in water, but this slight solubility of oxygen in water is enough to sustain the aquatic life. We will take one more example. Hydrogen chloride gas is highly soluble in water. Similarly, ammonia is also highly soluble in water. So, with the help of these examples, we can understand that different gases are soluble to different extent in water and other solvents. Now we will consider the factors on which solubility of a gas in a liquid depends. Solubility of a gas in a liquid depends on pressure and temperature. So first we will consider the effect of pressure on the solubility of a gas in a liquid. Students, the effect of pressure on the solubility of a gas in a liquid is explained with the help of Henry's law. Whatever points I have discussed with you are written here in this slide. You can go through this slide. So, for understanding the solubility of a gas in a liquid, consider a system which is shown here in figure. So, this is the figure A and this is the figure B. So, in figure A, you can see that there are two portions. Upper portion represents a gas which is present above the surface of a solution. The solution consists of a gas in a solvent. So it is clear to you that in this system, the upper portion represents a gas and the lower portion represents a solution of a gas in a solvent. And this system is in a state of dynamic equilibrium. Dynamic equilibrium means that at this temperature, the number of gas molecules which are entering in the solvent are equal to the number of molecules which are leaving this solution. Suppose P is the partial pressure exerted by gas over the surface of liquid at this temperature. Now, you are increasing the pressure over the surface of liquid. This increase in pressure is shown here. You can see here that in the figure B, we have increased the pressure over the surface of the liquid. So what will happen when you increase the pressure over the surface of the liquid? Volume of the system will decrease. Now, in this decreased volume, more number of molecules are present per unit volume. As more number of molecules of gas are present per unit volume above the surface of the liquid, as a result of which more number of molecules will strike the surface of liquid at this temperature. So hence more number of gas molecules will enter into the liquid, and we can say that solubility of gas has increased because of the increased pressure. Now what will happen? A new equilibrium will be established. At this new equilibrium, more number of molecules are present in the liquid, as a result of which the solubility of gas in the liquid has increased. Side by side, more number of molecules will leave this solution also. So, as a result of which what will happen, the partial pressure of the gas over the surface of liquid will also increase at this given temperature. So now we can conclude that the solubility of a gas in liquid is increased due to increase in pressure over the surface of a liquid at a given temperature. So this effect of pressure on solubility of a liquid was studied by Henry. He did a lot of study on such type of systems, and the effect of pressure on the solubility of a gas in a liquid is expressed in terms of Henry's law. There are a number of ways by which Henry's law can be explained. So few ways I'll discuss with you. First, you see, whatever points I have discussed with you are written here in these slides. So this is the first slide. This is the second slide. This is the third slide, in which it is shown that Henry was the first to give a quantitative relationship between pressure and solubility of a gas. So as I told you, there are a number of ways by which Henry's law can be expressed. So first way is that solubility of a gas in a liquid is directly proportional to the partial pressure of the gas which is present above the surface of the liquid at a given temperature. So this is the one of the way by which Henry's law can be expressed. Now there is one more way by which Henry's law can be expressed. What is that way? If you represent the solubility of a gas in terms of mole fraction. So we can represent the term solubility by mole fraction. So what is the another way of expressing Henry's law? Another way of expressing Henry's law is that mole fraction of a gas in a solution is directly proportional to partial pressure of the gas present above the surface of the solution at a given temperature. So there is no much difference. In the first way, we expresses the word solubility, and in the second way, we represented solubility in terms of mole fraction. So we said that at a constant temperature, mole fraction of a gas in a solution is directly proportional to the partial pressure of the gas present above the surface of the solution. Now students, I am going to explain the most common way of expressing the Henry's law. The most common way of expressing Henry's law is that partial pressure of the gas present above the surface of the liquid is directly proportional to mole fraction of the gas present in the solution at a given temperature. So it's clear with the help of this statement that the partial pressure of the gas which is present above the surface of the liquid is directly proportional to the mole fraction of the gas which is present in the solution at a constant temperature. So Henry's law can be expressed as P is directly proportional to X, or we can write as P is equal to KH into X. So what is KH here? KH represents the Henry's law constant. One more point I would like to mention here that Henry's law constant KH and mole fraction X are inversely proportional. So if the value of KH is higher than mole fraction of gas in the solution will be lower. I mean to say that higher the value of KH, lower will be the solubility of a gas in a liquid at that given temperature. Students, the effect of partial pressure on the solubility of a gas in a liquid at a constant temperature is shown with the help of this graphical representation. In this graph, you can see that here on this y-axis we have taken partial pressure of HCl in torr. And in the x-axis we are showing the mole fraction of HCl in its solution in cyclohexane. So you can see that as the partial pressure of HCl above the surface of its solution in cyclohexane increases at a constant temperature, the mole fraction of HCl in cyclohexane also increases. So we can say that P is directly proportional to X. So we can say that partial pressure of HCl gas above the surface of solution of HCl in cyclohexane is directly proportional to its mole fraction in the solution of HCl in cyclohexane at a given temperature. Students, as I previously discussed with you that mole fraction of a gas is inversely proportional to KH. And one more point I would like to mention here that KH has different values at different temperatures, and it has been found that higher the value of temperature, higher will be the value of KH. And as you know that KH and X are inversely proportional. I mean to say that higher the value of KH, lower will be the mole fraction of the gas in the solution, or in a simple language you can say that higher the value of KH, lower will be the solubility of gas in that solvent. It has been found that value of KH increases with increase in temperature. This can be supported by the value of KH for oxygen at two different temperatures. You can see that value of KH for oxygen at 293 Kelvin is given here. It is 34.86 kilobar. Now, the value of KH for oxygen at a higher temperature 303 Kelvin. You can see the value of KH is more at this higher temperature, which is 46.82 kilobar. Similarly, you can see the value of KH for nitrogen at two different temperatures. So, you can conclude that higher the temperature, higher will be the value of KH. And now you already know that at higher temperature, the solubility of gas in a liquid decreases. If you consider the case of oxygen, the solubility of oxygen in water will be more at a lower temperature. So that's the reason aquatic lives find more comfortable in cold waters rather than hot waters. So children, whatever points I have discussed you are written here in these slides. This is slide number 1. This is slide number 2. Now we will discuss the applications of Henry's law. Students, Henry's law finds a number of applications in our daily life. We will discuss few important applications. Students, all of you have seen that once you open the soda water bottle or soft drink bottle, CO2 gas fizzes out. After some time it turns flat. What's the reason? Students, solubility of CO2 gas in soft drink bottles or soda water bottles is increased by applying high pressure. So soda water bottles and soft drink bottles are sealed under high pressure. As a result of Henry's law, the solubility of CO2 gas in soft drink will increase. But once you open the soft drink bottles, the equilibrium is disturbed. Now the equilibrium has exposed to a lower pressure, as a result of which the excess CO2 will come out. And the process will continue until a new equilibrium is achieved. After some time, the soft drink bottle will turn flat. I hope it is clear to you. Now, another interesting application. You know that scuba divers, they go deep under sea water. So what will happen? In deep undersea water, they will be subjected to a very high pressure. As a result of which, again Henry's law is applicable there. Because of Henry's law, the solubility of gases in their blood, in their tissues will increase. As a result of which, what will happen? The large amount of gases will dissolve in their blood, will dissolve in their tissues. Now what will happen when they will come outside? When they will come outside, when they will come to the surface, the solubility of gases will decrease because now they are exposed to a lower pressure. So these dissolved gases will come out of their tissues, they will come out of their blood. So as a result of which, what will happen? The nitrogen gas which was present in their tissues, it will block their capillaries. And it will result in a medical condition which is called as bends. It is a very harmful condition. It may be lethal also, and it's a very painful condition. So to avoid this toxic effect of nitrogen, what scuba divers do? They use the cylinders which contains air which is diluted with helium gas. So as a result of which, once they come to the surface, this fateful conditions can be avoided. So children, whatever points I have discussed with you are written here in this slide. This is first slide, this is another slide. Okay, to avoid the bends, they use the cylinders which has the air which is diluted with helium. So this is the composition of gases which is present in the air used by scuba divers. Children, one more important application of Henry's law is that you know that at higher altitudes, the air pressure becomes less. As a result of which, the amount of oxygen will be less which is present at higher altitudes. So what will happen to mountaineers, or what will happen to the persons who live in mountains? Amount of oxygen which is dissolved in their tissues and blood will become less. As a result of which, they will suffer from a condition. In this condition, there will be less amount of oxygen in their tissues and blood, and this condition is known as anoxia. So what is the side effect of this anoxia? They will feel weakness, they will be unable to think, and this medical condition is known as anoxia. Students, thank you so much for watching this video. I hope each and every point is clear to you. Please subscribe my channel and like this video in case you liked it, and share this video with your friends also. Thank you so much. Have a nice day.